Welcome to solverfy.
All right, so problem 9 states part A is find the lowest energy level for a particle in a box if the particle is a billiard ball with a mass of 0.20 kilograms and the box has a width of 1.3 meters, the size of a billiard table. Assume that the billiard ball slides without friction rather than rolls, which means basically to ignore rotational components of the kinetic energy. So first we're going to start by writing down the energy levels for a particle in a box. These are given by E sub n is equal to n squared h squared over 8m L squared. Sorry, not the greatest of eights there. 8mL squared. All right, so where n is the energy level and h is Planck's constant, L is the width of your box, and m is the mass of your particle. So h is Planck's constant is 6.626 times 10 to the minus 34 joule seconds. All right, it's given in your book. M is the mass of your particle, which is 0.20 kilograms. And L is the length of the box, which is given as 1.3 meters, correct? Yes, 1.3 meters. All right, so for the lowest energy level, which is the n equals 1, is going to be equal to h squared over 8mL squared, which is going to be equal to 6.6, this is supposed to be parentheses, 26 times 10 to the minus 34 joule seconds squared divided by 8 times 0.20 kilograms times 1.3 meters squared. So working through all this, I won't do all the little math here, but this comes out to 1.6 times 10 to the minus 67 joules. Okay. All right. So now part B is since the energy part in part A is all kinetic, to what speed does this correspond? All right. So kinetic. Let's go ahead and go to the next step here. So kinetic energy is given by 1/2 mv squared. So we have a kinetic energy of 1.6, all right, 1.6 times 10 to the minus 67 joules is equal to 1/2 times 0.20. It's supposed to be a 2 kilograms times v squared. All right, so now we want to solve for v squared. I'm sorry, for v. So v is equal to the square root of, so we bring the 2 over, divide by mass, take the square root. So you have 2 times 1.6 times 10 to the minus 67 joules divided by the mass, which is 0.20 kilograms. All right, so going through these calculations, you get 1.3 times 10 to the minus 33 meters per second. Minus 33. 1.3 times 10 to the minus 33 meters per second. Now, the second part of part B is how much time would it take for at this speed for the ball to move from one side of the table to the other. All right, so velocity is meters per second. All right, so time is equal to velocity sorry. So multiply time over, divide v. So meters, distance divided by velocity, which is equal to 1.3. Here, this is going to be confusing. Let me change this variable. Let's go back here. There we go. So velocity is equal to distance divided by time. All right. Okay. So therefore, time is equal to distance divided by velocity. Multiply time divided by velocity. All right. So which is going to be equal to 1.3 meters divided by 1.3 times 10 to the minus 33 meters per second, which is going to equal 1.0 times 10 to the 33 seconds, which is probably about as old as much time as the age of the universe. 10 to the 34 seconds, I think, would be somewhere around that. All right, so now moving on to part C, we have what is the difference in energy between the n equals 2 and n equals 1 levels. All right, so we have delta E is equal to E n plus 1 minus E n, which in this instance is equal to energy of level 2, minus the energy of level 1, which is going to be equal to 4h squared divided by 8 ml squared minus h squared divided by 8 ml squared, which is going to be equal to 3 over 8 h squared over ml squared. So if you look at this, this is just 3 times the energy of number 1. So E2 minus E1 is equal to 3E1. All right. So this number is going to be equal, so 3E1 is equal to 3 times 1.6 times 10 to the minus 67 joules. That's supposed to be a 6. Is equal to 4.9 times 10 to the minus 67 joules. All right, so now the last question is a more conceptual part. It says, are quantum mechanical effects important for the game of billiards? Well, if you look at the time scales and the velocities and the energy scales, you can come to the conclusion that no, it's not really significant. These are not significant. Sorry, these are not significant. This is not a significant energy scale, so it's not going to affect the macroscopic scale of the game of billiards.